One of the most massive stars ever discovered is quietly falling apart at the edge of total collapse. And when it finally goes, the entire universe will feel it. It could implode into a black hole in a matter of seconds, or detonate in a supernova so violent it might be visible to the naked eye from Earth. And the most staggering part of all, scientists believe this could happen soon, not in billions of years. Soon. Subscribe to the channel right now and hit the notification bell so you never miss a discovery like this one, because the universe is packed with jaw-dropping secrets that science is only just beginning to uncover. The star in question is called WOH G64. Hard to pronounce, easy to fear. I'll call it Goliath. Goliath is a red supergiant located in the Large Magellanic Cloud, a satellite galaxy of the Milky Way sitting roughly 160,000 light-years away. That might sound distant, but in cosmic terms, it's practically our next-door neighbor. And right now, it is going through a silent collapse, a transformation that astronomers never expected to witness in real time. Red supergiants are stars at the end of their lives. Think of them as the cosmic elderly of the universe. They've already burned through most of their nuclear fuel, swelled to unimaginable sizes, and are preparing for the end. But not all endings are the same. Some are explosive. Others are far too quiet for what scientists expected, and it's exactly that mystery keeping astronomers up at night. When they scan the sky searching for red supergiants exploding, they find fewer than their models predict. Where are the blasts that should be happening? Why do some of these enormous stars simply vanish without a trace? Goliath is the kind of star that might finally answer those questions. For decades, it was classified as a standard red supergiant, despite absolutely nothing about it being standard. It carries roughly 25 times the mass of our Sun. Its size is so incomprehensible that if you dropped it into the center of our solar system, it would swallow everything out to Saturn's orbit. That means Mercury, Venus, Earth, Mars, the asteroid belt, and Jupiter would all exist inside it. Inside it. And even then, you still wouldn't have reached its surface. But recently, something changed. Scientific instruments began picking up strange signals coming from Goliath. The star's light signature, meaning the way it emits radiation across different wavelengths, started shifting in dramatic and unexpected ways, as if the star was switching identities right in front of the researchers watching it. And that's when scientists realized something extraordinary. Goliath probably isn't alone. Growing evidence suggests it's part of a symbiotic binary system, where two stars coexist in an intense, gravitationally destructive dance with one another. Binary systems are more common than most people realize. Estimates suggest more than half of all stars exist in pairs or groups. But a symbiotic binary system involving a red supergiant is something rare, unstable, and dangerous on a cosmic scale. In this type of system, the two stars orbit so closely that they begin interacting in violent ways. One can start stripping material from the other. Imagine two stars spinning around each other so tightly that each one's gravitational field begins tearing away the outer layers of its companion. The stolen material forms a kind of shared envelope, a cloud of gas and dust that wraps around both stars simultaneously. And that appears to be exactly what happened to Goliath. The red supergiant lost massive amounts of its outer material, and when you strip away the outer layers of a star like this, what's left underneath is hotter, denser, and far more unstable. That exposure transformed Goliath into something even rarer, a yellow hypergiant. If red supergiants are rare, yellow hypergiants are almost legendary. Only a few dozen confirmed examples exist across the entire Milky Way and nearby galaxies. They represent a chaotic transitional phase between the red supergiant stage and total destruction. It's as if the star is in full panic mode just before the final collapse. Yellow hypergiants are extraordinarily unstable objects. They pulse, expand, and contract in irregular cycles. They eject material into space through eruptions that can last for decades. Some grow so large they could contain billions of suns within their volume. But this phase doesn't last long. In astronomical terms, it's the blink of an eye. And the fact that we're watching Goliath go through this transition right now is something astronomers compare to winning a cosmic lottery. The question no one can answer with certainty is, what comes next? And here, every possibility is equally terrifying and fascinating. The first scenario is a supernova. If Goliath explodes in a supernova, the event would release more energy in a few seconds than the sun will emit across its entire 10 billion-year lifetime. The resulting shockwave would propagate through space at speeds approaching the speed of light. The resulting burst of light could outshine entire galaxies for weeks, and depending on factors still unknown, the remnant could be a neutron star or a pulsar spinning hundreds of times per second. The second possibility is even more extreme: direct collapse into a black hole. Stars with very high masses like Goliath sometimes simply don't explode. Gravity wins so quickly that there's no time for a traditional blast. The entire star implodes in fractions of a second, generating a stellar black hole with no warning. It would be as if Goliath just disappeared from the sky. A star that shone for millions of years, vanishing silently in a fraction of a second. This phenomenon, called a failed supernova or silent collapse, has been observed in other cases and may explain why astronomers don't find as many red supergiant supernovas as their models predict. The third possibility involves its companion star. If the two stars in the binary system get close enough, a stellar merger could occur. An event where both stars literally collide and fuse into a single, far more massive and chaotic entity. Stellar mergers are extraordinarily rare and unimaginably violent. When they happen, they can produce stars of entirely new types, generate jets of stellar material being launched across space, and create explosions that leave visible traces for centuries afterward. And there's one more detail that makes everything even more fascinating. A recent study using the James Webb Space Telescope, the most powerful observatory ever built by humanity, has started revealing that red supergiants like Goliath may be undergoing dramatic physical changes long before they actually explode. The James Webb can see through the thick dust clouds surrounding these stars, something previous telescopes simply could not do. And what it's finding is completely revolutionizing our understanding of how massive stars die. The idea that supernovas are sudden and unpredictable events is being replaced by the understanding that they have a visible preparation period, an agony phase that can last decades before the final collapse. Goliath appears to be in exactly that phase right now. And if the models are correct, the end may be less than a few thousand years away. On the cosmic clock, that's tomorrow morning. What scientists want most right now is to be ready, because capturing the exact moment of a supernova in real time is one of the greatest challenges in modern astronomy. It's like trying to photograph a lightning bolt at the precise instant it touches the ground. In 2023, an international team managed to do exactly that with another star, using the Very Large Telescope at the European Southern Observatory. They recorded the very first moments of a supernova in greater detail than ever before. And what they found surprised everyone. The explosion wasn't spherical. Instead of expanding like a perfect ball, the shockwave stretched into a shape more like an olive. When the ejected material collided with the gas surrounding the star, it flattened, but it held that elongated geometry throughout. That means the explosion had structure from the very beginning, and that structure reveals what was happening deep inside the star at the moment of collapse. It suggests the star's core, that dense region where nuclear fusion was occurring, wasn't perfectly symmetrical. There were turbulences, internal currents, perhaps intense magnetic fields directing the explosion outward in specific directions. This kind of discovery changes everything, because if we can predict the geometry of a supernova before it happens, we can use these events as even more precise measuring tools. Supernovas are already used by astronomers as cosmic rulers for measuring distances between galaxies. It was by studying supernovas in 1998 that scientists discovered something that shook all of physics. The universe isn't just expanding, it's expanding faster and faster, and nobody fully understands why. Goliath, therefore, is not just an interesting star. It's a window into the most fundamental and violent processes of the cosmos. A unique opportunity to understand how massive stars die, how black holes are born, and how the universe continuously reconfigures itself through stellar death and rebirth. Every atom of iron in your body, every particle of calcium in your bones, every trace of gold or platinum in Earth's crust, all of it came from stars that exploded before our sun even existed. When Goliath dies, it will seed space with the ingredients of future worlds. And we, here on Earth, 160,000 light-years away, will watch it happen. If we're paying attention, if the telescopes are pointed in the right direction, if humanity is still around when the show begins, the universe never stops. Stars are born, live and die in cycles that existed long before any human being ever looked up at the sky for the first time. And now, for the first time in history, we have the instruments to observe those cycles in extraordinary detail. We are living in the golden age of astronomy, where discoveries that once took generations now happen in years, months, sometimes weeks. If you made it this far, you already know that the universe is far more violent, far more dynamic, and far more fascinating than any textbook could ever convey. And there's so much more coming. In the next video, we're going to talk about another phenomenon that is challenging everything we thought we knew about the physics of the cosmos, something scientists recently found that simply should not exist according to any known theory. Subscribe to the channel right now and hit the notification bell so you don't miss that video, because when it drops, you'll want to be here for it.